Welcome guys. In group theory, first we will discuss about binary operation on a set, algebraic structure, identity and inverse. Binary operation on a set. A binary operation tells us how to combine any two elements of a set G to get a unique element again of the same set G, and it is denoted by O generally. If a comma b be any two elements of G with binary operation O, then a of v belongs to G for all a comma b belongs to G. Now we see here sum of two natural numbers. Natural numbers means counting numbers 1, 2, 3 and so on. Sum of two natural numbers is a binary operation for the set of natural number because the sum of two natural number is always a natural number. Since the sum of two natural number is always a natural number, therefore it is a binary operation for the set of natural number. Example given, 3 and 5 are two natural number and 3 plus 5 is equal to 8, which is also a natural number. But again we see that difference of two natural number is not defined as a binary operation for the set of natural number. And because the difference of two natural number is not necessarily a natural number. Example given, 3 and 5 are natural number and 5 minus 3 is equal to 2, which is a natural number. What 3 minus 5 is equal to minus 2 does not belongs to n. Again, we can see that difference of two real number r is defined as a binary operation for the set of real numbers r because the difference of two real numbers is always a real number. Example given, 3 and 5 are real number and difference of 3 and 5, 3 minus 5 is equal to minus 2, which is also a real number. Again 5 minus 3 is equal to 2, which is also a real number. Here we can see the same operation difference is a binary operation for the set of real number but is not a binary operation for the set of natural number. So thus binary operation is a operation which can be plus, minus or multiplication or any operation predefined. Now we discuss about algebraic structure. A non-empty set G together with at least one binary operation defined on it is called an algebraic structure. If G is a non-empty set with binary operation O, then G, O is an algebraic structure. We have seen plus is defined as a binary operation for the set of natural number. Plus and difference both are defined as a binary operation for the set of real numbers. Since the sum of two real numbers is always a real number and difference of two real numbers is also a real number. Similarly, the sum and difference is also defined as a binary operation for the set of integers since the sum of two integers is always an integer and the difference of two integers is also a integer. Therefore, n comma plus, r comma plus comma minus, I comma plus comma minus are all algebraic structures. But n comma minus is not an algebraic structure because difference of two natural number is not always a natural number. Now we discuss about identity of an algebraic structure. If G, O be an algebraic structure and E be the element of G, then A is said to be the identity of G if AOE is equal to EOA is equal to A for all A belongs to G. Not 0 is additive identity since A plus 0 is equal to 0 plus A is equal to A for all A belongs to R. Note second, 1 is multiplicative identity for all real numbers since A cross 1 is equal to 1 cross A is equal to A for all A belongs to R. Now inverse of an element, if G comma O be an algebraic structure with identity E and A be any element of G, if there exists an element B in G such that AOV is equal to VOA is equal to E, then B is said to be the inverse of A, that is A inverse is equal to V. Now we have to find additive inverse of A. Since additive identity is equal to 0, therefore additive inverse of A will be minus A. Since A plus minus A is equal to minus A plus A is equal to 0. Again we are to find multiplicative inverse of A. Since 1 is the multiplicative identity, therefore multiplicative inverse of A is equal to 1 upon A. Since A cross 1 upon A is equal to 1 upon A cross A is equal to 1. Therefore multiplicative inverse of any element A is 1 upon A. For example, if G comma A be an algebraic structure with any two elements A comma V belongs to G such that AOV, here binary operation is defined by AOV is equal to AV upon 2, that is product of AV half the product of AV. Then find the identity E and inverse of A. Solution. Since EV the identity, therefore AOE is equal to AE upon 2. By given relation, AOV is equal to AV upon 2. But EV the identity, therefore AOE is equal to A. This implies that A is equal to AE upon 2. This implies that E is equal to 2A upon A. A cancelled by A. This implies that A is equal to 2. That is, identity for this binary operation is equal to 2. Now we have found the inverse of A. AOA inverse is equal to A into A inverse upon 2 by definition. Now AOA inverse is equal to A into A inverse upon 2 by given condition. This implies that E is equal to AA inverse upon 2 since AOA inverse is equal to E by definition of inverse. This implies that A inverse is equal to 2E upon 2. Again we have E is equal to 2. Therefore A inverse is equal to 2 into 2. 2 to the 4 upon A. Thus we have A inverse is equal to 4 upon A for this element for this binary operation and A is equal to 2.